val, let's say QF. Need to download it over again. CTX. Right, if you have something like query schema, say person, and then you have the person, and then you could rename, whoops, you could rename individual properties, like you could say the field, oh wait, we need to define person, it's class person, is sober, is Russian, is human, so let's go, we could do something like val query schema equals to quote, query schema, person, and then let's say, because various databases have various ridiculous naming schemas, so some databases just arbitrarily decide to start all tables with TBL. Sounds like Microsoft Hungarian notation, no? So a TBL person. Right? And then sometimes you have all columns starting with call or something like that. So you can rename something like is sober to call is sober or something like that. In one column or multiple columns. And then when you do something like val q equals to quote qs dot filter p2p dot is sober, when you do q.ast, you'll see that there is a property alias, which is like a renamed fields. And then when you actually run it, you'll see that, okay, call is sober instead of is sober. So that's one way that you could rename columns or properties. So okay, that's what this thing is, which means that when we parse entity, we have to figure out how to do this stuff, but we don't care for now. By the way, if you are wondering what the heck this fancy little arrow is, well, this fancy little arrow is, well, it should be the equivalent of this, although I'm not sure if that'll work. No, that doesn't work. The arrow should be the equivalent of something that creates a tuple operator. If you do something like map foo bar as when, right, that is actually the same as doing that. That's the same as doing that. But it doesn't work that way here because details. The syntax tree for this is not the same as the syntax tree for that, to make a long story short. This evaluates to this, but the syntax tree is different. Oh, and by the way, if you want to know what the syntax tree for this is, then you can find out. The easiest way to do something like that is to go to your macro printing function. And let's re-enable this for a second. If you want to actually find out, again, super important to be able to find out what the heck is an actual syntax tree for a particular macro. So let's see, printing macro, blah, 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 blah. That's what does our printing. Let's actually try to print something out. Where do we use simple quill 1. Let's just reuse this. So then we could, let's say, import io.getquill.ast Wait, no. Excuse me. We can't do that. We have to. We're not doing that. I'm sorry. We have to. We have to do the equivalent of that. And if we want to do the equivalent of that, we have to pull in. We have to pull in the API that does that. And the API that does that, we have to pull out of our hat. And we can. Let's pull it out of our hat. 3.5, 3.6.0. This is the latest Quill RC3. What? I don't have such a branch. Okay. Oh, I don't have such a branch. Ooh, need to make one. Let's do re-release 3.6.0 RC3. There we go. So, query. This is the new version of the API. This will actually be shareable between the old and the new modules, but in this case, I have to use this thing directly. So this is just going to take a second. Let's see, blah, 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 blah. Query. Where's query schema? Def query schema. There it is. And query DSL. So there's the method signature for it. So then, if you want to actually see this thing and how it works, let's see. Where's entity query? There's our entity query. We have to actually define this thing if we want to see what the heck it is. Object toy DSL. So let's have that there. We don't have that exception. Throw in wait, we just do question mark, since we're not implementing this. And we need this guy here. So let's find that. Class entity query. Oh, come on. Oh, I know what's happening. Oh, wait, no, that should be fine. Class entity query. Module directory. Come on. What? Hello. Entity query model. Implements. Oh, it's a trait. Trait entity query. And there's entity query, and there's query that extends entity query, and so this is just the definition of the DSL that we've looked through before. So blah, 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 blah. Here's that, and here's that, and oh, I have entity query model, but that's fine. I'll just implement entity query here. And this extends query. Where's query? Query DSL. Where's entity query model? Here's entity query model. And okay, so that has all of those implementations. And where is query? Trait query. No. Come on. Trait query extends. No, not that one. We have two queries, right? One query is the AST element. one query is the actual DSL. Important to remember. There it is, sealed trait query. Right, there's query in all of its glory, all of its many methods. Again, let's pull this into the toy DSL. What is this non-quoted exception? This just throws, okay, we don't care about that. Forget about that. Entity query, entity query, entity query. Okay, everything is this stupid non-quoted exception. What is this thing? Blah, 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 non-quoted exception. Where do we have this thing? Come on. Class. Non-quoted exception. There we go. Let's import this as well. Finally. Okay. Blah, 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 blah. We've imported a whole bunch of crap. Join query. We need to import some more crap. Join query. Blah, 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 blah. And join query is just that. All to be able to see one little measly thing. We're importing the entire Quill DSL here. Okay. Blah, 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 blah. Okay, insert, you know what, we're not going to care about inserts and updates right now. Voila, finally. Okay, now, to do what we actually intended to do, which is this. Import toy DSL dot underscore. Now, right, what did we want to do? We wanted to do inline def, and we wanted to see, let's call it Q, and then we wanted to see query schema. Let's define our person name, string, age, and query schema of person, and then we wanted to say, oh, look at that! This is actually showing us what the heck it's supposed to be. Yay! TBL person. And then let's say dot name becomes call name or something like that. Now, print Mac Q. Let's actually print this thing. Oh, and print line Q, otherwise the compiler might wipe out the entire statement. Compile. La 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 la. Oh, more stuff that we haven't imported. Board. Don't care about that. There we go. Look at this beauty. Okay. So here's what this thingy is. Okay. Toy DSL.query schema, right? That's that. That makes sense. Right? And then person, use quill simple one.person. Okay, makes sense. TBL.person, right? That's that. And then take a look at what we've got inside. Right? We've got this, let's see. Person. Ooh, what's this? What's this? Anybody care to take a guess what this is? _.1. Let's copy this for a second. And let's instead say p2 p.name. Let's compile it again. La 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 la. Okay. Is that starting to make sense? P. Here's our P. P2P.name. Let's compare. This was that. This was that. Now, compare this to that. Well, actually, this entire thing is that. This entire thing is that. Compare and contrast. What is this? What is this exactly? What is this? What is this? What is this? Thoughts? Oh, and let's remove this. This is garbage. Sorry. Anyone? Thoughts?
On the pre-def?
Sure. Okay, so the pre-def, all that pre-def means is that this is some kind of class that was defined in this package.
Right.
So effectively, we can ignore that.
I'm not sure.
Let's simplify. Blah, blah, blah. String, blah, 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 blah. Blah, blah, blah. Blah, blah, blah. Blah, 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 blah. Blah, 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 right? We don't need the package name. We know that we defined it in use simple quill 1 in that package. We don't care about the package name. Blah, blah, blah. Blah, 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 blah. Yeah? Is this starting to look familiar? Let's simplify it a bit further. We don't actually need this. And we don't actually need this. So let's take that, move it back to there. Let's take that, move it back to there. Okay. Whoops. We did need one of those. So, compare and contrast.
I mean, they look basically the same.
Yes, they are the same. Somebody want to let's have a thought experiment for a second. Let's have a thought experiment. Let's see. Rename 3. And let's remove all this stuff here that we don't need. And let's say we decide to, wait, we don't need that either. So let's decide we do something like this. Let's say we have case class person. And then let's say we decide to do implicit class, let's do this. First name string, last name string, person extensions. Okay. Implicit class person extensions, P, person, let's, def proper name, or let's say title, equals to person.name plus space plus person, first name plus person.last name. Okay. Fine. And then we'd say, let's say we do something like val p equals to person, Joe, logs 3, and let's say we decide to do p dot title. And then, of course, we do print mac q. What is that going to look like? Any thoughts? Any ideas? How do implicit classes work? Right? Clearly we're getting this from an implicit class. How does it actually do that? How do implicit classes actually work? Thoughts? Well, implicit classes are an implicit class, so it creates an implicit round P, and then calls title on it. Right? This is what that means. Right? An implicit class is just a class that's created implicitly, okay? Okay. So then when we print this, what is the tree gonna look like?
I mean, however the new person X tree would look like. Right?
Voila! Voila! Right?
Okay,
Yeah.
Yeah.
Make sense?
Yeah.
Okay, so let's go back here, right? This is name, or p2p dot name, and there's this funny little arrow thingy. Where does the funny little arrow thingy come from? What could this be?
Is that an implicit?
Ah!
Is that an implicit class?
Where does funny little arrow come from? Can we right click here? We should be able to right click. Oh. This is re-indexing the whole project. Blah. Come on. Why can't I click on funny little arrow? Oh, it's importing it. Blah. Arrow assoc. Arrow assoc. This is where clicking on the funny little arrow will lead to once IntelliJ is done with its indexing. Oh, did we pause it? Oh. Oh, we paused indexing accidentally. There we go. So this funny little arrow of this funny little class is where it leads to. Because this arrow thingy is nothing more than this implicit class arrow ASSOC, or arrow association, which is an implicit class created for anything, right? A can be anything, and it can go to anything, right? How do you create an implicit property on anything that can go to anything? Let's say that I have a case class person name string age int, and I want to create, let's say, name, implicit class name, or let's say, I don't know what this is yet. Implicit class name ext. I don't know what this is yet, but I'll say it's something. Oops. Come on. Fine, I'll do this in Notepad. Have it your way. I have an implicit class. I want to create it on anything. And then I want to be able to say this, well, what does this thing do? Well, this actually has name. Okay. And name, let's say, takes another argument. Actually, should we? Fine. Name takes another argument, which is A, and let's call this B, which is also anything, and it says A plus empty string plus B. Okay. Well, how do I make something that creates name on anything? Oh, and this is kind of dumb, right? I want to be able to do something like, oh, this is a bad example, of course, but let's not call it name. Let's call it and that, right? So you should be able to do something like foo dot and that bar, right? And it should return foo and bar. You should be able to say person Joe 1, 2, 3 and that bar, right? And it should say something like, let's say, the toString of this, toString plus that plus bar. If I want to do something like that, right? So I'm doing and that. How do I make something that's going to be on anything? Ideas?
I mean, you're already using an implicit class.
Well, we could just do that.
Yeah.
That would work, right? Oops. Right? And then we could do,
Yeah.
and that would work. But let's say we want to do a little better, right? Let's say that we want to actually be able to say, I don't know, something like, oh, Okay, no, I can't demonstrate this without getting more complex. I don't want to get more complex right now. So I'm just going to do some finger waving. But a better way to do this is to use a generic.
A what?
Generics.
Oh.
The reason why it's better to do generics, because then if you have a generic, you could do something like you could do something like TT implicit TT type tag of A, and then you could do something like if pt dot type dot is a subtype of, let's say, type of person, then a dot as instance of person dot name, val a name equals to, and then you could say else a dot to string, and you could do a name plus b or something like that. So if you have generic parameters, you can get additional stuff, as opposed to if it's just any. You can't do much with that. Although you could call instance of, but whatever. That's another whole big bag of worms. But anyway, so A plus that plus B. Okay, so name ext, fine. So what are we going to have there? Paste. Okay, that's sort of the same thing. Now, what is that going to look like? Let's try that. P dot and then bar. So can we do that? Oh, what is it complaining about now? Oh, value plus is not a member of A. Okay. ToString. Actually call ToStrings. SCA3 is stricter about that. And what is this? And that. Excuse me. Okay. Okay, now this is getting interesting. Okay. So this was generated from that. So we generated and that. This was the implicit class that created and that. Okay, let's get rid of the extra noise. Let's get rid of that. Let's get rid of that. Let's get rid of that. Okay. Oh, the object foo you can ignore, by the way. Sorry. Please ignore this. This is inserted. This is extra. Okay. Is that starting to make sense?
Yeah.
Okay.
But
Huh?
well, never mind.
So then we could say change and that to this funny looking arrow, or let's just make it a little different. Let's just change it to this funny looking arrow that doesn't really mean anything. Okay. So this is now a funny looking arrow. And this is now a funny looking arrow. And again, simplify. We can get rid of the package, get rid of that, get rid of that. Get rid of that. Da-da, da-da-da, da-da-da-da-da. Is that starting to make sense?
Yep.
Okay, now let's compare to what we saw before. Again, you can ignore all the object foos. Now compare what's going on with this arrow thingy and what that turned into versus this arrow thingy and what that turned into. Any thoughts? Compare this, or more accurately this, and that, right? This is the expansion versus this and that.
I mean, yeah, the expansion makes sense.
Yeah. In light of the fact that arrow association is nothing more than...
I mean, it's just again, at the end of the day, it's just a binary operator, right?
Yes.
And
again, Scala does not have operators.
Yeah, it just has methods. I mean, yeah, functions, yeah.
Yeah, in Scala, an operator is a method. Right? There's our arrow association. The only funny thing is, what happens if, we happen to be inside of a method here, which means we can do an underscore instead of like a whole proper object, right? So if you take a look, right, it expanded to P, right? Our implicit class expanded to P, right? In this case, it has to be P, right? Because this is on the outside. In here, we happen to be inside of a method, which means that inside of a method, you don't have to name the variable. You can use an underscore, right? If it has a name, right, if we put it into an implicit class, surrounded it with an implicit class, it has a name, okay, it'll expand to the thing of that name. What if we surrounded it with an implicit class and the variable has no name? Well, we just have to assign it one, right? So we just assign it the name _1, or the first underscore. Let's say that we added another underscore. Let's paste this here just so that we don't lose it. Let's see, we added another underscore. This was p2p.name, fine. Let's change it back to an underscore. Oops. Underscore. Oh, by the way, we could do p2p.name and then again p2p.name. Or let's say another column. Let's say age to call age. Okay. La 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 la. Oopsie. Okay. So pair association. What is this complaining about? Person is already defined. Oh, oops. Toy DSL. Oh, wait, do we have two toy DSLs now? Oh. Wait a minute. We have two. Oh, wait. Did we forget? Why DS? Oh, I need to. Okay, I need to do a clean. Whatever. Blah 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 blah. P2p.name, P2p.age. Query schema. What happened here? Ah, there we go. Again, what happens if we have multiple? Okay. La 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 la. Okay, is this making sense? Right? We have multiple.
Yeah.
So this is how the parse tree works in this particular situation. Now notice that we have _1 here. _1. Well, let's see what happens when we do la 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 la. Okay. Ooh, look at that. _1, _2. Right? It starts to name them different names. Okay. Fine. So anyhow, this is a way to understand how trees look. Anyhow, let's clean, compile. All of our errors should display. No, hold on. What is it complaining about here? Clean, compile. My first macro. Sorry, 1 second. I could find this class somewhere else. No. Toy DSL is defined. Toy DSL is already defined as object toy DSL. How did I? Error toy DSL is defined as object toy DSL. But I cleaned it. Clean compile. What? Did not find American class path. Why is this breaking? Patient code that was inlined from. Let's just take this whole thing, comment it out, and compile. Okay, copy this back in, and then compile again. Okay. Well, this is odd. Okay, object toy DSL. So here's toy DSL. And there's our definition of toy DSL. There's our definition of the query DSL. Why is this finding an error? Okay, what happens if we do toy DSL too? Let's do toy DSL too. Okay. Okay, let's take it back to ToyDSL. 1 second, let's relaunch SVT. Clean, compile. What on earth? Object ToyDSL. How is it already defined? This is the only place that I have it defined. ToyDSL. Oh, no, I do have it defined in more than one. Okay. Okay, I accidentally defined it. Okay. Whoopsie! I accidentally defined it here. Okay, my bad. Fine. You can use this for something else. I accidentally defined it here. Okay. I accidentally defined it here, which means that I can move what I had before. Which means I can move what I had before, which was now not that. I had this before. Let's call this ToyDSL 2. Wait, no, I don't have that at all. I can just compile this. And right, this is going to be use simple quill done. Come on. All right. Okay.